almost perfect for solar,
Nice.
right? We're looking for three things. The first thing is that we need to make sure we're facing south, solar south. Like
Makes sense.
15 degrees off of solar south.
Pretty good.
Almost perfect.
All right.
All right. Second thing, we want to make sure we have the right pitch. All right. We want to be between 30 and 45 degrees.
You're talking the pitch of the roof.
That's right. That's right. And we're at 34 degrees. Perfect.
Okay.
We want to make sure we have enough pitch to actually shed the snow in the wintertime here.
All right.
All right. And the third thing is obstructions. All right. We want trees and all the other obstructions that are in the way. In our case, we are above the tree line, so we have very little shading factor.
Shade is not good for solar, right?
Obviously not.
So how did you calculate all of these things?
So I was up on the roof earlier, and this device right here has a sun eye. This goes up on the roof, is going to show us how much sunlight actually hits our roof over the course of a year. And what it gives us is this. And this is showing from 8 a.m. to 4 p.m. for different times of the year. And it's also going to show the obstructions. And you can see that green blob over there. That's a tree that's giving us some shading to the roof.
That's shade over there,
Right?
okay.
And the number we care about is the total solar resource fraction. That TSRF is 88% for our roof. So what does that mean? Over the course of an entire year, 88% of the total sun will hit that roof, 12% shaded.
So if we were to build this, say, down on the ground in an open field, exactly how we wanted it, that's 100.
That's 100%.
And 88's pretty good.
That's right. That's right. We're very good.
So obviously these panels will take sunlight, convert it into electricity, and then we'll ship it down into the barn. Are we gonna use it there? Are we gonna ship it to the utility? How's it work?
This is a grid-tied system, so you're exactly right. So it's gonna hit, the sunlight hits our panels, it then gets converted into electricity, it's then used in the barn right there on site.
If we need it.
If we need it. If we're not using it, it spins our meter backwards, and that power goes to the grid and is used by our neighbors.
And we get a credit.
We get a credit for that from the utility, exactly.
And then at night when the sun's down and we need electricity, where's that coming from?
There's no power from the roof, but we're gonna use everything from the grid like we always have.
Okay, and so at the end of the year, we may end up ahead of the game or substantially discounted our prices.
That's right, that's right.
And obviously it looks like work is already underway.
Yeah, the solar crew started a couple days ago. First thing they did was they installed stanchions into the roof rafters, lagged them right into the roof rafters. Then they installed a watertight flashing system around the stanchions to make it watertight. Next thing, they put the aluminum racking system that mounts directly to the stanchions. Last piece is the panels get mounted to those stanchions. Solar panels work by taking sunlight and creating it into electricity. They create DC or direct current power. What we need to use in our house is AC or alternating current power. And typically the way it works is the PV panels are mounted up here and they're strung together in series, wired in series, down to a central inverter down in the basement.
And that's what will convert the DC to AC power for us in the house.
That's right. The problem with that is that if one panel gets shaded, one panel malfunctions and knocks out the entire array, they all get reduced to the weakest link.
Really? So if two panels, let's say over here in this corner, are in the shade and they're operating at what, 50% efficiency, this whole array drops down to 50% efficiency?
That's right. You're only as good as your weakest link.
No, that's not good.
Not good at all. So in the last 5 years, they've come out with microinverters. This is what one looks like.
So this is what's now converting our DC to AC electricity.
That's right. One of these per panel, creating the DC to AC power right here at each panel individually.
So you just mount them underneath each panel.
That's right. That's right. The power about this is that they're wired in parallel. So if one panel gets shaded, it doesn't knock out the entire array.
Okay.
All right?
All right.
So it's very simple to install. It's going to mount right to the racking system like this.
Wow, that is easy, huh?
It's so simple. And so these are the two leads. This is the positive and the negative on the DC direct current side that connects to the solar panel.
Just plug them right in?
Plug them right in, yep, two positive leads there. And this is the alternating current, the AC power that's going to feed to the house, and it connects right here.
And with those two things connected, that panel is shipping electricity down to our barn.
That's right. So Kevin, this is our solar panel. There's gonna be one of 28 up on the roof, all right? The capacity of this panel is 260 watts, all right? And this right here is one of our solar cells. This is a silicon wafer.
Yep.
You can see there's 60 of them, and the electricity that's generated travels on these wires back down to the main bus and out to our positive and our negative leads that get connected to our microinverter.
Perfect. Got a little hoist right here. Is this one ready to go up?
It is, it is. Set it up. We start at the roof ridge and work our way down. That way we're using the rails to support our feet. We place the solar panels on the racks, then we make two connections to the DC leads, and then the panels are held by 4 bolts. Come on up.
Ross, nice job. We got 28 panels installed. What's next?
So we got a couple things left. We're gonna bring some wires down from the roof into the barn.
Yep.
We're gonna make some final electrical connections, and then we have to get an electrical inspection, and then we're up and live.
Please click on the link below the video to watch the full content. If you are interested,